Of the first quarter of our physics lectures, and today this is the first part, and today we're going to talk about motion in two dimensions, or two-dimensional kinematics. The previous lecture, in which we discussed displacement, velocity, and acceleration, in that lecture we were only speaking in terms of motion in one dimension along a straight line. But today we are going to expand on that understanding and talk about what occurs when there is a motion in both the x and the y axis, and how to do calculations in both axes. We are also going to talk about falling objects and projectiles, which are by definition objects that travel in two dimensions. To introduce this topic, we need to think about a practical situation in which a pedestrian would walk from the starting point, which is at the 0 point on the graph here on the x-axis, to a destination that is on the 5 on the y-axis, also designated the destination. This walking requires a 9-block trip east, then turning north and traveling 5 blocks north. It's very common for this type of motion to occur. All the blocks here, because this is a square block situation, are the same size. And as you know from our previous lecture, as we talk about the straight line between the starting point and the destination, we're talking about the displacement, whereas if you follow the actual path that the person takes, it's called the distance. Just a little mathematical reminder, a little geometry reminder. Pythagoras in Greece developed a Pythagorean theorem which states that in a right triangle, the length of the hypotenuse is equal to the square root of the sum of the squares of the sides of the right triangle. So, if the path that is taken by an individual is a right triangle, then the displacement can be found by using Pythagoras' theorem. The straight line path would be a path that would be followed by an aerial object like a helicopter or a bird. And it would be shorter than the 14 blocks that was walked by a pedestrian. The displacement, and we'll do the calculation in just a minute, the displacement would be 10.3 blocks, which is 9 squared plus 5 squared, the square root of that sum. And the distance that would be traveled would be 14 blocks. Now, one thing that's important to also understand when we talk about motion in two dimensions is that there's an independence of perpendicular motion. Now, what we're showing here is two balls. One ball, the red ball, is simply dropped. The second ball is thrown in a horizontal fashion. In both these balls, once the ball is released, the blue ball is released, the only force that is acting on both of these balls is gravity. So one ball falling from rest falls directly down, while the other, which is given an initial horizontal velocity, heads from left to right and falls down at the same time. The point of this diagram is to show that the vertical motion down and the horizontal motion from left to right are independent of each other. One way to say this and to show this is to say that if you have a gun in your hand and a bullet in your other hand, and you fire the gun horizontally and drop the bullet from your other hand at the same time, if the bullet that's fired from the gun does not hit anything while it's traveling, both of those bullets hit the ground at the same time. And many times when people think about that, it's hard for them to imagine that, but it's true that the vertical motion caused by gravity is unaffected by the horizontal motion. Now we're going to talk about how to determine the displacement if you know the path, or how to determine the displacement if you know the distance. And it's important to understand that there are actually two methods in which to do this. One method is called the graphical method, and we'll talk about the graphical method first. The second method is called the analytical method. The graphical method is a method that is a mechanical method used like when you're drawing a diagram on a map, such as what is shown in the picture here. The displacement is essentially by measuring and using a scale to determine the length of the path and then adding those up, etc. Now, in order to do that, we have to understand how to add and subtract vectors. So let's go back to our city block example, and you will recall that if a person walks 9 blocks east and 5 blocks north, the displacement is 10.3 blocks as calculated by Pythagoras' theorem. And I'll show you how to calculate this in the future, but the angle of this displacement is 29.1 degrees north of east. Remember that any vector quantity, and displacement is a vector quantity, has to include both a magnitude and a direction. So in order to do this, first you have to select a scale on your piece of paper or on where you're doing your work. And an example of a scale would be to say that 1 centimeter on your piece of paper represents 1 block. Then you know that the person initially walked 9 blocks from left to right. You assign a starting point and you walk 9 blocks or 9 centimeters along the x-axis. The x-axis being where the angle between the x-axis and the path is equal to 0. And that's the first vector you would draw. Then from the head of that vector, you draw a second line perpendicular to the first line that is 90 degrees from the first line, and you would draw that line exactly 5 centimeters long, or 5 blocks, based on your scale. The third step is to take a straight edge and connect the starting point to the end point. Then you would get that line would represent what is called the resultant of the vector addition that you've done, but also represents the displacement of the person walking along this path. Then, using the same scale, you would then measure this line, and the line should measure approximately or close to 10.3 centimeters. Then you would use your scale and say that the displacement is 10.3 centimeters. Then you would get out a protractor and measure the angle between the x-axis and your resultant displacement line. And this angle would be approximately 29.1 degrees. So this, using the graphical method, shows you the displacement, both its magnitude and its angle, or its direction. Notice that we haven't done any straight mathematical calculations here, which is why this is called the graphical method. Now remember, when you're adding a pair of vectors, what you're doing is you're putting the tail of the second vector on the head of the first vector. This is called the head to tail method. So again, to review, you start out by drawing in diagram A, you draw the first vector from the starting point exactly 9 units. Then you go to where the head of that, put the tail of the second vector, shown in B, perpendicular, which is north of the first line. You draw that line, and then C, you draw the connecting line from the starting point to the head of the second vector and measure that, and that shows you exactly the distance that exactly the magnitude of the displacement, and this is the resultant, or D vector. Its direction is then determined using a protractor, 29.1 degrees. So let's take a second example. What is the total displacement of a person who starts out walking 49 degrees north of east for 25 meters, then changes to 15 degrees north of east for 23 meters, and lastly turns 68 degrees south of east for 32 meters. Now what I've done in these diagrams is shown each of these vectors individually without adding them together. So the first 25 meters, 49 degrees north of east, looks like the one on the left. The 23 meters, 15 degrees north of east, looks like the one in the middle. And then 68 degrees south of east for 32 meters looks like the one on the right. Now what we have to do is we have to add these three together. So we take the first one, then we put the second one, the tail of the second one, on the head of the first one, draw it, then take the tail of the third one, put it on the head of the second one, and draw it, and then look at the resultant. And the next slide shows that process. So you start with A, you draw it. Again, you have to have a scale, and I suggested a scale of 1 centimeter equals 1 meter. Now, unless you have a fairly large piece of paper, that's probably not the best scale to use. You might want to use something like a half or a quarter of a centimeter equals 1 meter. But then you draw A, which is going to be exactly 25 centimeters long, 49 degrees above the x-axis. Then you put the tail of B on the head of A, and you draw a 23 centimeter line, and you use a parallel line parallel to the x-axis in order to measure the angle. And then lastly, you draw the third C in the same way. And then your resultant will look like this. You draw a connecting line from the starting point to the head of C. The resultant can then be measured with a measuring stick, and using the same scale, you find that it's 50 meters. Again, you get your protractor out and measure this angle, and the angle is going to be 7 degrees south of east. So your resultant answer is going to be 50 meters, 7 degrees south of east. Now you can actually, the order of the three vectors can be changed, and you will get the same answer. And this is an example where instead of going A, B, C, we went C, A, B. And as you can see with the drawing, we got the exact same answer. So a vector addition is what is known as commutative, which means that it is path independent. The resultant is path independent. A plus B plus C is equal to C plus A plus B. Now that's not always true in certain situations, but in vector addition like this, it is always true. It is always commutative. Now, if we want to subtract a vector, it's simply, the process is adding a negative vector. And a negative of any vector is a vector of the same magnitude, parallel in exactly the opposite direction. So as you can see here, B and minus B are exactly the same magnitude, and the only difference is that minus B is parallel to B, but in exactly the opposite direction. So you can use a subtraction in order to find an answer as well. And here's an example of that. A woman is sailing a boat at night and is following the directions to a dock. The instructions read to first sail 27.5 meters, 66 degrees north of east from her current location, and then travel 30 meters in a direction 112 degrees north of east, 22 degrees west of north. If the woman makes a mistake and travels in the opposite direction for the second leg of the trip, well, where will she end up? So what we're showing in this diagram is the initial two vectors that she should have taken. But regrettably, in her second vector, instead of B, she did minus B. So minus B would look like this. So if the woman mistakenly travels in the wrong direction for her second leg, she will be traveling 68 degrees south of east. So exactly the opposite that she should have been traveling. This is represented in the line above. So if we want to find out where she ended up, we would add the two vectors like this. We would draw A in the proper direction, but then instead of B, we would add negative B. And then the resultant would be from the starting point, or the tail of A, to the head of B. And you would see that using the same ruler and protractor that you end up with a 23 meters, 7.5 degrees south of east. If you wanted to determine the location of the dock, instead of using a negative B, you'd use a positive B, which is what is shown here. So you start with A and then add positive B to A, and then the resultant would be A plus B, and it's 52.9 meters, and it's 90.1 degrees north of east, or almost exactly due north. Okay, I'm going to wrap up this part right now. When I return for the part 2, we'll start with this slide, which is the first slide where we talk about the second method, which is the analytical method. And the analytical method uses mathematics instead of drawing in order to find your answers.